Okay, this video is part 2 of lesson 4-4, where we are proving triangles congruent using a couple shortcuts. We just got through talking about the side, side, side shortcut. We can prove all 3 sides of one triangle are congruent to all 3 sides of another triangle, and that means that the entire 2 triangles are congruent to each other. Another shortcut is called the Sas Postulate. This stands for side, angle, side. So you can read it here. This page is in the folder that you're watching this video in. I have 2 sides, and the included angle, we're going to talk about what that means, of a triangle are congruent to 2 sides and the included angle of another triangle. Then we know the triangles are congruent. Okay, so what does that mean, the included angle? I'm going to draw a little picture on the back here. Whenever we're talking about side, angle, side, if we've got 2 triangles, when we name sides and angles, we just read them in order as we go around a triangle in a circle, right? So we're just looking at a triangle in order. So if this side is marked congruent to this side, and this side is marked congruent to this side, and we're using SAS, side, angle, side, well, if I'm reading this around, I got a side and then another side, the angle in between them has to be congruent as well. So now I'm reading it in order. It's literally a side, an angle, and a side as I go around the triangle. Side, angle, side. So this is called an included angle because it's in between the 2 sides that we're talking about. Just like the A is in between the 2 S's, the angle is in between the 2 sides. Same thing, right? So here, we've got a couple examples to do. For each diagram, determine which pairs of triangles can be proved congruent by side, angle, side. So here, we've got this side congruent to this side. They're marked. We've got this side congruent to this side. So far, so good. And the angle between the 2 right here is marked congruent, but it is not marked congruent here. Over here, it's a different angle. So since they're not the same, this one's side, angle, side, but this one's angle, side, side, we cannot mark these congruent. Not congruent by side, angle, side. Has to literally have a side, an angle, and a side in order. Doesn't matter whether you're reading a triangle clockwise or counter, it doesn't matter, but it has to be in the order SAS. Okay, so for here, we've got this side marked congruent to this side. We've got the bottom here marked congruent to the top here. And we've got the angle between them, 90 degrees, marked congruent to this angle between them, which is also 90 degrees. So this is a side, an angle, and a side, marked congruent to a side, an angle, and a side. So yes, these are congruent by SAS. I'm going to say FDE is congruent to JHG by SAS, side, angle, side. And then we have one more. These guys right here. So we've got this top is being marked congruent to this guy. Great. This diagonal, when it's used in the bottom, is marked congruent to the diagonal when it's used in the top. And angle 2 here is marked congruent to this angle, right? So we've got a side, an angle, and a side, congruent to a side, an angle, and a side in that order. Side, angle, side, side, angle, side. This is an included angle. It's in between the 2 sides. Same here. So yes, we can say triangle PSR is congruent to triangle. Now I went PSR, so I'm going to do the same thing here, RQP by side, angle, side. So we can say this entire triangle is congruent just because of one side, an angle, and another side. Okay, write the specified type of proof. We're writing a 2-column proof for both of these. I'm just going to shortcut it here. Statement, reason. Number 1 is given, and P is congruent to PM, and NP is perpendicular to PL. Okay, and they're already marked for us. This guy is congruent to this guy, and this line and this line are congruent, which tells us that these two angles are 90 degrees. So in step 2, I'm going to say angle NPL is congruent to angle MPL. Why is that? Because of the definition of perpendicular lines. They create 90-degree angles. Definition of perpendicular lines. Okay, they're both 90 degrees. I probably could have said they equaled 90 degrees, but they're congruent to each other. Okay, so I also know that PL right here is used in both triangles. I've already marked this side congruent to this side. I've marked this angle congruent to this angle. Side, angle, I need another side. And PL here is used in both triangles, and it's the same PL. So we can say PL is congruent to itself. That's reflexive. And once we've said that, now we have enough to say that our two triangles are congruent. So triangle NPL is congruent to triangle MPL. And that's because of side, angle, side. Side, angle, side. Two sides and the angle between them are congruent to two sides and the angle between them. Side, angle, side. Good, one more. I know this is a pain in the butt, you guys, but you're gonna see problems like this, so I just wanna give you something to reference that you can go back anytime and watch me solve these. And hopefully they make sense to you, and if not, please let me know. All right, so I've got statements, reasons. One is always the given. AB minus CD. Okay, well, I think this is supposed to be congruent. I don't think it was marked completely. AB is congruent to CD, and it's also marked here congruent, so I know that it was supposed to be written that way. And that's given, and then AB is parallel to CD. AB parallel to CD. And that's all given. So how is that going to help me? Well, if AB is parallel to CD, then I know that the angles here are alternate interior angles, because here's my transversal. And I can say that they're congruent, right? So I have to prove the two triangles are congruent using side, angle, side. I've already said that this side is congruent to this side. I see that both triangles share a side, AD. So in step 2, I'm going to go ahead and get that one out of the way. AD is congruent to AD, and that's reflexive. When you say something's congruent to itself, that's a reflexive property. And it is congruent, whether we use it in the bottom triangle or the top. And next, I have two sides marked congruent. Now I've got this side, and this side. So in each triangle, I need the included angle marked congruent, right? And I was told that this top line is congruent to the bottom. So this angle connecting the transversal and the top line has to be congruent to this angle down here. So in step 3, I'm going to say angle BAD is congruent to angle BAD is congruent to CDA. And that's because they are alternate interior angle. That's because of the alternate interior angle theorem. All right, so once I know that those are congruent, once I know that, yeah, these two angles are congruent, now I've marked a side, and the included angle, congruent to a side, and the included angle. So I can say that the triangles are congruent, triangle ACD. I'm just copying the proof. DBA. And that's because of side, angle, side. Because I proved side, angle, side, congruent to side, angle, side. So this triangle is congruent to this triangle. All right, and lastly, these are not proofs, so you should be kind of happy. Determine whether these two triangles are congruent, explain. Okay, so it gives us triangle ABC, it gives us A, B, and C, the coordinates. To figure out if they are congruent with the coordinates only, I have to measure the length of each side, right? And how the heck do I measure the length of a side when all I have is the coordinates? Ding, 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 distance formula. Okay, so I'm going to find the distance between AB, BC, and AC of that triangle and compare it to the distance of all these, right? So for AB, I'm going to use distance formula, y minus y squared plus x minus x squared, or vice versa. -3 minus -1, and 3 minus 3. -3 plus 1, -2 squares 4. This is 0. Square root of 4 equals 2. So the length of AB is 2. BC, distance formula, x minus x squared, -1 minus -3, y minus y squared. -1 plus 3 is 2 squares 4 is 8. So this is square root of 8. For BC. And then AC would be the third side of this triangle. Y minus y or x minus x, doesn't matter which one you start with. I'm going to do x minus x, -3 minus -3, and 3 minus 1. 3 minus 1 is 2, 2 squared is 4, so AC equals 2. Okay, so these are the length of all three sides of one triangle. Now I have to compare it to all three sides of another triangle. And it doesn't matter which order I do the sides in. So I'm going to do KL. X minus x, 1 minus 3 squared plus y minus y, 4 minus 4 squared. This is 0, so it cancels out. 1 minus 3 is -2. -2 squared is 4. Square root of 4, which is 2. Okay, so far so good. It's the same as one of the sides. Next side, we have KL. Now we need to find LM. X minus x, 3 minus 1. Y minus y, 4 minus 6. 3 minus 1 squared is 2. 2 squared is 4. -2, 4, this is square root of 8. Okay, so far so good. I have one of those over here in the red. Oops. And lastly, I need to find the length of KM. Square root 1 minus 1 plus 4 minus 6. And square root of 4 equals 2. So yes, I've got three sides of this triangle. Two of the sides are 2. The third side square root of 8. I've got three sides of this triangle. Two of the sides are 2. The third one is square root of 8. Doesn't really matter what order they're in, because three sides of one triangle match three sides of another. So determine whether they are congruent. We're just going to say yes because of side, angle, side. That's it, okay? For the sake of time, I think I'm just going to skip this one, but we would solve it the exact same way. There's no trick questions to it. You're literally just finding the length of each side, so the distance from one end point to the other. So in a triangle, if it gives us 3 points here, A, B, C, we have side AB, side BC, and side AC. You got to find the length of all three sides. Same thing with KLM. You're going to have side KL, LM, and KM, right? Find the length of all three sides, compare, and if they match, then you know they're congruent by SSS. If they do not match, then you cannot say they are congruent by SSS. So you would just say no. Let me know if you have questions.